Are you rolling? Okay, cool. So what we have here, we've got a switch connected to the PLC, and this PLC right now is it's got input X1 wired to that switch. You'll notice we have an indicator. We have humorously labeled self-destruct 1, because you want more than one self-destruct, of course. And when we turn the switch on and off, you're seeing that indicator turn on and off as well. I want to show how we configured this. So first, in the PLC, this is wired up to input X1. That means the memory location, X1 bit in memory, is going to be the bit the HMI panel will need to read from the PLC through the serial cable to be able to tell the indicator light object what to do. Inside the HMI software over here, if we take a look at the tag name database, you can see if we scroll to the bottom, all the tags we've entered for this project so far. We have a tag called POT, which is described in a separate video, which is a potentiometer position, reading an analog voltage. And then we have 4 switches, which happen to be mapped to X1, X2, X3, and X4. As I just said, the switch I was manipulating is connected to input X1 on the PLC, and the tag name we created for that is a discrete tag data type with a name of switch underscore 1 mapped to address X1 on the PLC. It's a read-only attribute. It's able to read that data from the PLC. It would make no sense to make that read-write because we cannot have the HMI writing data to that bit in the PLC because that X1 bit in the PLC is getting its data from a hardwired switch. It can only get its data from a hardwired switch. So that's a read-only attribute from the HMI's perspective. So we close that out. We take a look at the object we put on the screen, double-clicking on that. That is an indicator light. We gave it a label called self-destruct. We can actually turn that label on and off if we wish. We have the ability to tell what the text will be when it's off, what the text will be when it's on, and here's where we specify the tag name. So here we could, if we wanted to, select any one of these appropriate tags, any one of these discrete tags for that switch object, or the indicator object on the screen. Once we did that, we sent the HMI program project to the panel, and then it established communications with the PLC, and you have what we see right here. On-off switch status, toggling the bit status of bit X1 in the PLC. The HMI reads that bit through the serial cable and makes the indicator turn green or gray, on or off, as you can see. So, just like we did with our potentiometer position and the analog meter, we have a way for the HMI panel to read data from the PLC. The principal difference is here we're reading discrete data, there we're reading floating point data.